Hello everyone, Triple N here and welcome to my ongoing efforts to make a BCM flyback converter. So as you can see, my lab is in a complete mess right now. It always is while testing. It's inevitable actually, because testing never goes the way you plan things. So maybe I should just begin by explaining my setup. There's my oscilloscope turned on, all three channels. So the yellow channel is a drain. The blue channel is the current waveform and the purple or pink channel is whatever I want to measure. I'll explain that later. Multimeter to check the voltage on the capacitors. Multimeter is right here. Always keep it turned on so that I don't electrocute myself, because these things after all they hold 30 joules of energy, not to be reckoned with. Power supply turned on to 12 volts. You can see the yellow channel just went up there, indicating that the power supply is on. And this is the actual charging circuit. Never mind. The charging circuit itself. This is the flyback transformer, which is floating in the air right now because I haven't put it inside version. No, I haven't soldered it to version 4 yet. And no, I'm not going to sit down and edit this video. I just want it to be a single take because I'm too lazy, too many problems to deal with, so I thought I'd just show you some of them. I always put on ear protection, broken, spliced together earphones, so that I don't accidentally deafen myself. So you turn the circuit on. You can see the purple channel just went up right there. And then using my screwdriver I short two headers as tradition goes. And you can see the waveforms. I'm going to pause it now. Charge to 200 volts. I first discharge it before I do anything else. Very good safety measure. I don't know if you can see the exact waveforms. I'll try zooming in a little bit. And you can very clearly see this is not boundary mode conduction. If it was boundary mode conduction, the next cycle would start right here when the secondary energy transfer is done. But it's starting a lot later. Maybe that has to do a lot with the way I'm hooking things up. Let me probe a different spot. I move the probe around, and this is a spot where I'm getting feedback from the tertiary winding. Maybe I'll just show you how the feedback is hooked up on this piece of paper. Focus. Oh, come on, focus. Yeah, better. I'm not sure if you can see this, and like I said, I'm not going to bother editing this. Let it be all natural. So this is my feedback winding. It's in phase with the primary winding. A diode, a resistor, and this portion of the circuit is grounded. There's supposed to be an additional capacitor, but I omitted it. Frequency, response, rigging, all that kind of stuff. And this is a spot where I do my apparently BCM sensing. So the waveform looks something like this. It goes negative while the secondary energy transfer is taking place. And my comparator, which is right here, this thing, zero crosses that waveform and you get the output. Okay, so now let me concentrate on the feedback. Check the run stop once. Set it to the right volts. Set it to the right volts per division. And all this noise that you see right here is from my ATX power supply. That's completely inevitable. Again, things are never easy for a power systems engineer, are they? So now I turn it on and I stop it. So you can very clearly see the feedback waveform, a very noisy feedback waveform. So the positive and negative peaks are clamped by two diodes. Let me show you. The negative peak is clamped by this diode and the positive peak is clamped by another diode which I've added to ground. Both of them are 1N4148 common diodes. So yes, you can see this waveform goes, this waveform goes positive for 0.7 volts and negative 0.7 volts, and there's a little ringing over here and it goes to 0 volts. Now what I'm supposed to be doing is I'm supposed to be switching on the next cycle right at this point, but something keeps my comparator off for all this while. Let me see if I can show you that. Change the volts per division again, and now I move this wire to the output of the comparator, and I'm doing all this while the capacitors are charged. I didn't notice. Don't do that, very dangerous. I discharge the caps. Yes, that should be enough. And I record a new set of waveforms. And start charging. And stop. Yes, discharge the caps, and now you can see that something is keeping the comparator low for this whole duration. I have no idea what's doing that, but yeah, I'd be glad if you have any solutions you can suggest. I've been playing around with this for nearly 24 hours now. I still haven't found a solution, so let's go back to the whole bench. Yes, so this, oh my god, yeah, so much for not editing this. Right, this Arduino Nano does nothing, it's not connected. I was using it for single pulse testing. This is the oscillator board, if you can see it. Yes, I think you can. This is the comparator section. This is these two wires are from the feedback winding. This is the feedback section, and this is another comparator which I was testing with to see if I can actually achieve what I wanted to. So I've tried nearly everything to remove the noise, including low pass filters and such, and nothing seems to be working. I have a suspicion that it's because I'm doing this all on a breadboard. There's lots of extra wires, tray inductance, capacitance, resistance, things you can't easily deal with. Okay, I'm gonna charge this once more so that you can see all the waveforms over the whole charging period. Yeah, it's a bit glitchy here and there, but that's trigger. If you noticed carefully, the feedback from the tertiary winding works quite well, but it's not switching off when I want it to. That's an odd thing. I've got no other node in this circuit to probe. So yes, I guess that's it. Tough life of a power systems engineer. So till I fix this problem, thank you for watching.